Hi, welcome back to Scientific Panchayat. Again, I have Sam guest. Yesterday we had to stop in between our conversation. So now we are resuming again. And in last conversation, we talk about a bit of his research and how he started his career and how he get that he's more suited to the research field. And we also talk about like his school time and the bachelor's
Mhm.
level time. Now we'll be continuing what we left in our last episode. We discussed about basic cosmology things. Now we are going to use those basic things in order to connect his research work so that our audience can understand his research work more easily. So let's get started. Welcome back.
Thank you so much.
So last time we stopped at where we were discussing about the basic cosmological things.
Mhm.
We talk about the cosmic inflation, galaxy cluster, data stuff, and
Yes.
all other things. Now, I think it's better if we move forward from here and try to connect your research,
Mhm.
whatever we discussed so far. I think we provided the good background so
Yes.
that people can understand and relate to your work.
Mhm. Yes. So, well, I like one aspect of my research, that is that I connect a very theoretical aspect of cosmology with the observations that we talked the other day, about these maps of galaxies.
Yeah,
So, really, the core of my work consists in studying a phase just at the beginning of the universe, which is called cosmic inflation, and how this epoch, this phase of the universe, leave an imprint on the uh, galaxy clusters that we see. So by studying the clusters, as we talked the other day, we can get information about this phase, about this cosmic inflation phase, and this connection between this hypothetical scenario and these observations is the core of my work. I try to link these two aspects.
I would like to expand on what is meant by cosmic inflation for our audience.
Yeah, cosmic inflation is a theory that we have about the early universe because, in general, when we study cosmology now in the 21st century, we have a model to know how the universe started, how it evolves until the present day. But we have some struggles that we need to solve. And these struggles, that is, we can impose theory called cosmic inflation, which really consists in an very early in the universe, a very fast expansion of the universe, of space. And this epoch is what is called cosmic inflation. Also, it motivates some observations that we do, some statistics of these galaxies can be traced back to the effects of this epoch of cosmic inflation.
So, what I'm remembering now at this point, the cosmic inflation theory brought up in order to remove some degeneracies, I would say, or the things that wouldn't be explainable by other things. That
Mhm.
was the whole purpose of bringing the cosmic inflation by Alan Guth and others, right?
Mhm.
So when we include this cosmic inflation, we avoiding monopole problem,
Mhm.
we avoid the causality problem as well.
Yes.
So I would like to discuss these two things in
Mhm.
a very simple way so that our audience
Perfect.
can relate. What was the sole purpose to bring this cosmic inflation? Because so far, I think we don't have any observational evidences for cosmic inflation.
Yes, not direct ones, because we have to go so much into the past, but
Yeah.
we have indirect evidence of cosmic inflation.
Okay. So we'll first talk about why this cosmic inflation brought up
Yes.
and what are the indirect evidences.
So, for example, I think in the last episode we talked about the homogeneity of the
Yeah.
universe. That really, if you zoom at different patches of the universe, you get
Yeah.
more or less the same result.
Yeah.
And this is one of the effects that I talk about, that the standard model in cosmology, the model that we work with, is our reference framework. We don't understand how these regions, so separated in space, can be so equal one to another. And inflation solves this problem because inflation can be understood as a phase in which everything was
Close
squeezed
enough.
closer than we thought.
Okay, and then the universe suddenly expand by a huge amount. So
That's
the
it.
pieces which are close enough, they
That's
are
it.
sharing the same properties.
And without inflation, we don't have like enough time to them to be in contact. So
Okay.
by inflation, we have like, you can understand it as you have more time to connect things. And that's
Okay.
an explanation of how different patches of the universe
But
so far
looks
away
similar.
looks almost the same.
Yeah, and that's the concept of homogeneity. That's the first principle of cosmology.
Yeah.
I would say in research field, we'd say like it's the first cosmic principle where we consider the universe to be homogeneous.
Yes, and I think all modern cosmology comes from the general relativity theory
Yeah.
and this principle of homogeneity of the universe. Yes.
Okay. And what do you think about the monopoles? Like we expand on the causality effect now, like the patches which are connected early in the time before the inflation and after the inflation, they remain connected because the expansion was so much at a higher rate, but they were sharing the information in past before the inflation. That's
Yes.
why we are seeing this patch of the universe and the other patch of the universe look similar. So what about the monopole? Because I always have difficulties to understand monopole during my master's studies.
Yeah, the monopoles are the magnetic monopoles are just a strange relic of the universe, which comes from having different phases. It's like when you have water and ice together, and they are the same but in different phase. I think it's called no different
Yeah.
state of matter
Okay.
No.
So it's kind of a transition point for
Yeah,
it.
yeah. In the universe, we can have also different materials, different components at different phases. Let's say that is that way. And in between the middle, in between the separation between those two phases, you can get like funny things happening there. You can
Okay.
find different kind of relics and
Mhm.
different distortions of space itself.
Okay.
Okay, some of them, there are many of them, but some of them are called monopoles. Sorry.
Okay.
And these objects are predicted to be everywhere in the universe. And really, we look at the universe with telescopes and with these surveys that we took the other day, and we don't observe any monopole.
Okay.
So what's going on? We have really a really bad theory predicting this monopole. So that's and again why inflation is important, because inflation again. Okay, these monopoles were present there, but the inflation was so violent and so fast,
They
expanding the
put them
space.
further apart, right?
That's it. That their density, but that the quantity of monopoles that we can observe is zero. But there are
But we are not
so diluted.
sensitive enough to detect them.
That's it. They are so diluted in the universe that maybe we have in the whole universe just one or even zero in the universe that we can see. So really, inflation again give us like more time to these monopoles to get out of what we can see.
Okay.
So solves another problem. And another interesting problem is related with the shape of the universe, because we can
Okay.
have the universe in different shapes.
Yeah.
And really, inflation is a mechanism. Is a good example is like we can be like ants over the top of a balloon.
Mm-hmm.
And okay, the ants on the top of a balloon can detect that the balloon can have a curvature or is flat.
Yeah.
Okay, but if we let's guess that the universe can have some curvature like a balloon, and if we can be ants on top of this balloon, and we can, if we move and we can move around the balloon, we can like detect this curvature, no? Like two ants go to the same direction, and we end up like crossing paths or whatever, and we can like sense that we have some curvature. But again, inflation, what it does at the end is called inflation because it inflates the space of the universe. Inflation will inflate this balloon a lot. And what happens when a balloon is inflated like huge proportions? We are small ants.
Yeah.
As much as we walk in the balloon, the curvature, if there can be a curvature, but we cannot detect it because it's so flat.
Yeah.
In our distances.
Yeah. So it's like a local effect. So when you are at a local position, then you're seeing surface to be flat.
That's it.
It's like a globe. Like if you look globe at once, you'll see these lines are curving. But
That's
if
it.
you just stand on a particular position there, then you'll see it's flat.
That's it. And that's another because the observations that we have of the shape of the universe is that it's flat. And also, it's this by chance. And inflation, again, is a mechanism that no matter which is the curvature, it flattens the curvature. So, again, give us like an explanation of why the universe is observed to be flat or near to be flat.
It's good to know. Like I didn't think in past about this way, like why the universe is flat. I'm just taking the GR courses where we are doing a lot of mathematical things and this curvature parameter needs to be zero there, k equals to zero. So
Yeah.
we are not going in that GR specific area, otherwise it becomes the very mathematics and physics
Yeah.
heavy lecture. So now I would like to expand on how we are going to connect your research work so far, what we have discussed in the previous episode and just now.
Okay, so well, one statistical tool that we can get from the galaxy clusters, that these 3D maps that we checked the other day, is just how much the galaxies are cluttered as a function of how separate they are.
Okay.
Okay, so what we can study is just measure the whole map and measure distances and see, oh, it's quite likely to find another galaxy at this distance from the original galaxies. Okay, now let's try the double of the distance.
Okay.
Oh, at the double of distance is more strange to find another galaxy.
So what are the numbers as you're increasing the distance to find the galaxies at those distances, right?
Yeah, I mean, we can have a statistical test to test all the distances and see how likely it is to find another galaxy, depending on this galaxy. Okay, and this is the tool which is called power spectrum. Okay, but just measures how likely it is to find a galaxy depending on the distance to the others. Okay,
so it's give you a probability basically.
Yes. For example, if you can imagine all the galaxies being at the same distance, like a constant grid, like all at the same distances and all of this, we can have like it's super likely to find out the precise distance, which is the same distance, but at the others it will be zero. So, but it's more complicated like this because in general we can have at different distances, we can have galaxies at all different distances, but in some of them it's a little bit more likely to find another. So at the end, we are studying the distribution of these galaxies across all space.
Okay, and you are trying to obtain as a measure of distance how likely you are finding the galaxies at those particular distances.
That's it.
That's what you are gaining from your power spectrum. And anything else you'll be getting from power spectrum apart from the likelihood of finding a galaxy at that particular distance.
Yes, with this measure, again, I trace it back to my interest, really, my real interest in science, which is again why. Okay, we measure this. This is like how, no, they are distributed and how much and all of this. But now, why they are distributed in this way? And that's the question that I address in my research.
Okay.
Because real inflation predicts a certain pattern of this distribution. Okay, and this pattern more or less is like you can find galaxies. Is more or less the same likelihood of find them at any given distance. Okay, and if we measure, it's a little bit tricky because what we measure, the galaxies nowadays, we have to get rid of late time effects. Okay, like we distinguish between early universe and the late evolution. We have with this distribution of galaxies, we have like to trace back how these galaxies move. We can see how they are moving now, but we can go to the past, see how they move in the past, and we can try to obtain how they were much in the past. Okay, so tracing back the initial positions of these objects, we can obtain this signal coming from the very early universe, and we can obtain with very precise measurements that in fact this likelihood is nearly as predicted by inflation. Like at all distances, we have more or less the same likelihood to find another galaxy.
Okay, so it's another reason. Like I won't say it's another reason. I would like to say it's an indirect way of measured inflation, right?
Yes.
So this is one of the examples.
Yes, because if we're not, because of inflation, we wouldn't have a mechanism to understand why this distribution is like that.
Okay.
The galaxies are distributed this way. Will be just like a finding, but without any reason behind. Okay, but inflation gives really a physical meaning of this. Okay, this comes from a certain effect happening during inflation.
Okay, so it won't be wrong if I say you are also indirectly working to measure your cosmic inflation using indirect evidences.
Yes, of course. I mean, inflation happened so at the beginning of the universe that all the energy and matter was condensed into a very tiny region, and the energies involved in that epoch are quite more high than the ones that we can test in any laboratory whatsoever, or even in the particle colliders or any experiments that we had. So really we had just to have indirect evidences, no? That the big lab, which is the universe, we have to study what we have, what the light of these galaxies.
So for cosmologists, this whole universe is your lab.
Yeah, yes, and we only have one.
Yeah.
But really we have to get the most of the information that we have.
Okay. Yeah, that's great. Like, it's whenever I'm just talking about these kind of stuff, I'm really excited and fascinated. Like, we are just like a very small, like a you can just consider ourselves like a sand grain in this cosmos.
Yes, yes, it's overwhelming to think about how huge it is and how small we are in comparison.
Yeah, and so far we haven't found any other life apart from Earth.
Yeah.
So that's always giving me like the universe is so vast. We have the some part where the matter is higher, where some matter is lower. So
Mhm.
whenever I'm looking at the sky
Yes.
and during nights, each star or most of the stars
Mhm.
most likely having their own planetary system.
Yeah, I think the likelihood of a star to have a planet is near one. I mean,
Okay.
near one, it means that each star has average one planet more or less. You can have stars without them,
Yeah.
but only also you have stars with 3, 4, or we look at our star, no?
In
So
our
many
own
planets.
galaxy, we have many stars. Like, I don't know the exact number, but I think it's in millions or billions.
Yeah, I think it's hundreds of millions per galaxy,
Okay.
and we have hundreds of billions of galaxies.
So in our entire Milky Way galaxy, we are the only
Mhm.
species that resides in resides on planet Earth. Other than we didn't find any conclusive evidence in order to support any kind of life
Mhm.
apart from us. Isn't this amazing? Like, we are sitting here and discussing about the cosmos
Yes.
and recording this episode so that the future generation can get something out of it.
Yes, and well, in my opinion, when you study the universe, no, this talk about the alien life or whatever sounds very exoterical, no. But really,
It
if
sounds
you
like
think how big the universe is, it's strange to think that we are alone in that.
yeah,
So really, I mean, for me, in my opinion, I am almost convinced that there is more life in other planets.
but we are not able to detect
Yes,
them
that's it.
precisely.
And what we said in the other episode, that the speed of light limits
Yeah,
or
limits us.
how information can travel.
Yeah.
And we really are so far away. I mean, to connect with Andromeda, that we
Yeah.
think we talk a little bit about Andromeda the other day. But for sure, I think it's more than 100 light years.
Yes.
And maybe even, I think it's thousands of light
Yeah.
years. And really, it's the closest galaxy. It's hard to have a communication with that.
Yeah,
As we said, they are seeing dinosaurs in
Yeah.
planet Earth.
So
And we
if
are looking at
someone-
Andromeda.
at the
Yeah,
moment-
and for other galaxies that our light reaches them,
Yeah.
even it wasn't even the Earth, maybe it wasn't formed.
So at that time, I won't even think the Earth existed.
Yes.
Even our solar system created at that time.
We have detected the stars and galaxies which have twice the age of the Earth. So for them, we have the planet is not even formed, not
Yeah.
even the sun.
Because Earth is about 4.5 billion years old.
Yes, and we have galaxies and 10,000 million years, no?
Yeah.
So really
for about 9 billion years.
Yes, and maybe in those galaxies, if there is life in some galaxy, they say, oh, we don't see any life.
Yeah, it sounds like we are just having a discussion on sci-fi movie.
Yes, it seems like a science fiction, but really, I mean, I think in our lifetime maybe we can discover some forms of life, no, and indirectly, and maybe we can have some estimates on what kind of air this life breathes.
Okay.
But really, we won't have much information. Like
Yeah.
maybe it's this planet, and it's likely that it has life. But probably in our lifetimes, in 10, 20, 30 years, it will be discovered.
And Elon Musk is also planning nuke the Mars.
No, in the next decade, will be
Yeah,
people landing on Mars.
On Mars.
I think.
It's crazy. Personally, we won't be spending so much money on Mars. Instead, we can spend that money to make Earth a better place.
Yes, but I think we have it's always interesting, no, to think also about the this race of
Human race.
the
Right.
human race to conquer the space. Yes, it's a lot of money, but really, I think there are steps needed to mankind, no, to
Yeah, I
maybe not needed, but
completely
really.
don't agree with you,
Mhm,
but I not also completely agreeing with you. Like when
mhm.
we recent years, the pollution,
Yes.
climate change,
Mhm.
global warming, so we can spend a bunch of or a quite a good portion of that money that we are spending on this space mission. We can stop that money and can spend that money on this kind of things.
But also there is a lot of money spent in other aspects. I think it hasn't has to be a competition because okay, maybe if you prioritize other things, but really also to go to the moon or go to Mars can be challenging, and we can learn things that we can apply here on Earth.
Yeah.
So maybe okay, maybe what is the sense to go to Mars? Maybe there is a not a direct purpose, but really we can learn more than we think.
Yeah. Yeah,
And
people
just
are
more
also
knowledge.
thinking to make a gravitational wave detector on the moon. Yeah, and I know the person who is like one of the core member of this idea was Karanjani, I guess. He is
Mhm.
an Indian astrophysicist
Uh-huh.
who's working on gravitational wave stuff. So might be we can use that kind of technology in order to support that gravitational wave detector. That might be useful for that.
Yeah, so of
We
course.
we never know what's coming up next.
Yes, and also, well, related with the science that I talk about the cosmic inflation, again, it's quite natural to have people thinking, and why do you study this? Okay, so this is a fast expansion of the very early universe, and why it's important to you, what it's important to mankind, what is important to know about this? No, it's a very natural question,
Yeah.
and really, like so many other things, we have to know to have a fundamental knowledge of nature, and even if you need a practical reason, at the end, inflation, we think that it composed of a particle which is called inflaton. It's very easy
Yeah,
because it
inflaton.
produces
Yeah.
inflation. But this particle, if we can reproduce this particle or know what is this particle, it really produces that the space and also time is stretched a lot.
Mhm.
So you can imagine maybe in the future that if this particle is known and we can produce this particle or whatever, I don't know, maybe we can just travel to other places at the instantaneously.
It's like a blink of an eye.
So really we can start to control the space on time. And so this is just a speculation. But can you imagine 1,000 years ago explaining about electricity?
For
That's
those.
it. Maybe some people 1,000 years ago sit in a fire talking, well, it was science fiction to control electricity and energy like this. So maybe it's the case between us now.
Yeah.
But who knows? So, okay, so this research doesn't have any practical application nowadays and maybe in the future, but they are the building blocks of the scientific knowledge that at the end can suppose big leaps forward, like electricity, like many other stuff, like to produce chemical elements. To, I mean, it's just fundamental advance of mankind, and really these building blocks of studying these epochs of the universe. That's the base to start to explore this.
Okay. Now back to your research again. So what else you are studying in your research apart from power spectrum?
Yeah, it's cool. It's a collaboration. It's called JPass, J slash pass, which is how alambre photometrics. Yeah, it's well. At the end, it's another survey. It's the main telescope is here, based in Spain, and it's a collaboration mainly in Spain and Brazil. And in the last years, so many Chinese scientists have get involved into this collaboration. The next meeting will be in Shanghai.
Ah, okay. I hope
Yes.
you see you there then.
Let's see. Let's see. Let's see. And yes, and this I just participate a little bit. My contribution is infimal, is so little, but
But
really
I think
this.
these infinitesimal contribution makes a huge progress at the end.
I also hope that. Yeah, but really in the collaboration, it was just
Yeah.
at the beginning of my research, and really my work there was just to like do some small test on some filters. So it's really very nice work. But it's very interesting because this mission, this telescope, it had different filters to observe the light of the galaxies. And really, it's nice because typically there is two approaches to studying light. One is to study just the light, to receive light and measure the velocity and all of this. And other approach is just to study light in different frequencies. And you get from the radio frequencies up to the X-ray or even beyond, and you can study the light at different frequencies. And the nice part of this mission is that it combines both. It measures light of all the spectrum, but it takes like bands, different filters.
Okay.
It covers different bands, in concretely 57 bands. So
Okay.
it's like a mixture of the two approaches, and with this we have like the good aspects of both frameworks. We can analyze quite quick the light of different sources, because if you analyze all the spectrum, it's quite slow.
Okay.
But if you use this method, it's quite quick. You get the light in 57 filters. It goes more in the ultraviolet and to the microwave a little bit, I think. But it's nice because it's quite quick and we can gather many information.
Okay.
So this one is an interesting work for applying my research and try to look for the inflation signal on these results with these filters.
So in simple words, I can just say these optical filters are the different goggles.
Yeah.
You just observing the same part of the sky by
Yes.
just keep changing your goggles. Or
that's a perfect example. Yes, its filter receives light, let's say from pale blue to green, and all of this light just goes into one filter.
Yeah.
The next filter is more like green and a little bit of yellow.
Yeah.
So it is divided in this way in 57 filters.
Okay. Yeah, I just must say, like, you have a really excited work. Like, it's, as you just said, it's a mixture of like the combination or by combining the different optical windows.
Yes, it's a good compromise between both.
So I think you are just trying to find the optimal path or the optimal way.
Yes, because it's very tricky. You can combine the filters in many combinations, spend more time looking at a region. So it's quite complicated. But yes, this design of filters is very good insight to study cosmic inflation. Yes.
And I wish you all the best for your thesis defense that will be going
Thank
to
you so
defend
much.
in next few months, I guess. Yeah, I hope it will turn really good at the end. Now we'll be discussing research life struggle in this section. Like, people think the research must be a cool thing, like from outside of academia. The people who's just listening to us, they might think the research looks exciting, but from inside it can be slow, lonely, or sometimes you are feeling like you are left behind from others. So what are your intakes, like, as we talk about the uncertainty most of the time? So it can be full of uncertainty, or maybe what you expected taking you longer to achieve those goals.
Mm-hmm.
So how you deal these kind of situation? Because in research life, I can understand that. Specifically in the people who just started their career in research life, I would say the early career researcher,
yes,
are struggling a lot with this kind of situations.
Yes. Well, I guess my general vision here is like it's another job, and it has the good part of being a job, but also it has the bad part of being a job, which is that really we are forced to do things and to work with things and have a struggle with things that really are not much stimulated and just a routine stuff, not very interesting to do. Like, as I think I said it the other day, just to struggle with figures, just to struggle with properly write some things, properly the design of the document, properly measuring and doing some tests is, in my opinion, for me, it's a little bit boring. But also, as I said also in the previous episode, if you learn to do this, it's just like another word. You just learn to do that, and if you are disciplined and all of this, you don't have to be a genius at all. You just have to put attention and to learn. And also, I think by people outside academia, outside the research life, I think they get the best of it because we just communicate the exciting results and the interesting science, and they don't have to do this.
That's why I put that question.
So from the inside, okay, maybe you can have a more profound knowledge and to really understand how the universe and nature works, but it comes with a price, no? And I think in general, most of the jobs have aspects like this. Okay, maybe you can have a good expert or whatever, or maybe you have your partner, your working partner, you have a good time with this partner. But in general, you have like to, I think we said it the other day, if you are really passionate, that you have real interest in things, I think it motivates you to keep going.
Yeah, but what I felt, like I observe other PhD students like us
Yes.
or the PhD scholars, they are doing everything precisely. Like
Mhm.
they are doing their best. But sometimes, let's say you set some deadlines or some targets for yourself,
Mhm.
but you are not able to achieve them at deadline that you decide. That really, like, drops your motivation sometimes. Like you're just thinking, yes, I'm just sitting here doing whatever I can do, what I'm doing my best, but still I'm really far away what I want to achieve.
Yeah, my way to see that is that again, it's just you are a worker doing some work, and some deadlines are not feasible, and sometimes it's very frustrating to see that no matter how hard you try and how many hours you keep doing this, you are not able to pursuing these goals. So I think it's also important to early researchers to have an honest conversation with the supervisors and really to set feasible goals, because I think that's a real problem in academia. Also now science, physics and cosmology, in the past it was different, no, because people were working more isolated, no, they working more in isolation, their papers with a colleague. But now science is more organized,
Or
cosmology
collaboration.
in collaboration, sometimes of hundreds, thousands of people.
Yeah.
And really in there's some deadlines are really hard to fulfill, because if a big telescope has to measure or has to release data in this date, you really have to stick to that goal. But again, okay, this is a problem because really you need to have this done in this date. Or once again, you are a worker, and in my opinion, you should have with your time that you are working, if you are really putting the effort, reasonable goal should be given to you.
Okay.
And sometimes you have to assess if it's honest that you can
You
achieve this
have to
goal.
be honest with yourself, because sometimes
Yes,
we decided the target that are not feasible.
that's it. Maybe you need help, maybe you need a other person doing this, or maybe simply you just say, in 2 months I cannot do this, it's not feasible for me. But that's in the early part of your career, it's not easy to assess, so you need the more, I think that's one of the main roles of the supervisors, really saying that, oh, maybe to achieve this in 2 months, yeah, so
Yeah.
let's try to go another way. And again, in my thesis also we have some big ideas in the thesis, and at the end you have to reassess, you have to reconduct. And I think in general nobody gets the thesis that they wanted, the perfect thesis, but at least you have one that you are proud of and that you achieve things, maybe not as big as you intended, but that's part of science also. Reassess and put achieving goals.
Okay. So, like, here I wrote few questions that I
Yes.
collected from some of my friends, some of from my side, which
Yeah.
I think the mostly people would like to listen about those kind of things, because in academia nobody talks about these kind of things.
Let's go for it.
So, first question that I would like to know: what is your daily research life actually?
My daily research life.
Yeah.
So I wake up. My daily research. Oh, that's I'm glad that you hear, because yeah. So my daily research probably is when I start doing my work. Probably I take a look at the mails. I see if everything
Yeah.
it's going, nothing urgent, no.
Yeah.
Because I try to like when I stop working, I don't work. I try not to work anymore until the next day, and then the next day be focused on that. Also, sometimes I take a look of the papers recently published in the last day. If anything is interesting for my work, maybe I just save the reference or whatever. And then, well, I take probably at the beginning of my morning, I start to work in the morning. I try to start with something easy. An important part of my day also is to talk with my supervisors and with other colleagues and take decisions about what we are doing. Okay, because yesterday I obtained an interesting plot, but now we are not sure that's the plot that we want. So I will say that yeah, that's an important part of my day. And then again, some days I can have like a small breakthrough, or really okay. So we get this figure, we understand this effect. But other days we really have like, oh, I try this, I try to code this. A big part also of modern science is
Yes,
also coding and
coding.
programming. And yeah, there are days in just you also gave steps back. I have a code I didn't understand. I tried to understand it today, and now I understand even less. So it's not a linear process. So yeah, and also, well, we have also, I think, also to talk with supervisor and other colleagues. They can help you. Sometimes when I'm stuck at something, I don't understand some effect that I am observing. I just tell this to my office partner or whatever, and just in this quick discussion, they can come with some ideas. Well, I have the luck that my supervisors really are with me in the building. I have one just in the office next to me. And really, how often? Sometimes we meet each day. Just we can be just like, how are you doing? Any progress on this? And just take a quick look. But yeah, we'll say like in a week we can meet at least once or two. Yeah, yeah.
Okay. Have you ever felt like you got stuck something and you
Mhm.
think and you were not able to understand why this particular thing is
Oof.
happening in your plot? That
Yes,
might sound very obvious thing
I can
at
I
a,
can tell
from the
many.
ref. If you look from the perspective of your supervisor,
Yeah.
so at that point, are have you ever hesitated to discuss? Because when people is starting their career, they really hesitate. Like,
Yes, yes.
so I would just like to know how you deal with this. Like,
Yeah, again, I think it's important to be honest because yeah, that happens a lot. That you, for example, I didn't know how to program very well at the beginning of my PhD, and well, I have plenty of easy problems that I wouldn't be able to solve. And really, I think again, it's important to say that okay, if I'm new with this, okay, probably I will make more mistakes, and some of them very basics. No, in retrospective, you see that okay, it was so basic. But I think again, it's so nice to have a communication with your supervisors. To be honest, if you have to learn in some language and you won't know it, I think it's we are more afraid to say it. Oh, and also, this thing is also important. I had talked with many experts that really you talk about one topic and they really say, but I am not an expert in this.
yeah,
And in a topic they don't know, they have zero problem to say, probably you will know more than me in this topic. And also another effect is that, yeah, at least for me and I know for others, that you always think that your partner or the other knows much than you. Then, okay, this is my code, but for sure the code of the other guy is much better than yours. And that's not true neither.
yeah.
And the other thing is the same of you. Point. I mean, I think it's just in our head. Yes.
Okay. So the my next question: do you spend more time in reading, coding, or doing some calculation, deriving some equations,
Mhm.
or discussing the ideas with your colleagues here?
I will say, in general, in modern cosmology, the ones that are doing our own original research, we spend more of our time coding. I think that's main activity of.
Of your research part.
I would say the second part is discussing maybe about what we are getting.
Yeah.
But yeah, I will say that's the main part. And this romantic part of reading a book at midnight with a candle or whatever, no, like to have a great discovery. This is not as real as it's devised in movies, no, or whatever.
Okay, so the next question that I'm asking this on the behalf of Indian students who is in their early career stage, like they are maybe in their first or second year in PhD, and I know Indian academy isn't a good place. These kind of things. So once they achieve this, like when they started their journey,
Yes.
and at prestigious Indian institutes,
Mhm.
and sometimes, or I think most of the times, they feel like, what if the things don't work as I expected? So, for example, I would ask this question in another way. So, what happens when the things don't work for you, even for months or
Or yes.
years?
Um, So you have the hard option, which is to try to fight, to try to fix it, to try to understand what's going on. Most of the times is your problem. You are not efficient. Your program is not working as you intended. You have a limitation of computing power. I will say that is the minority that really there is a physical problem there, because many times it's your approach. But I will say that the hard part is to fight with it. Sometimes you cannot fix it, but the other part is again reassess and be able to be quick and to say this thing I cannot do this thing. And I think even it seems like the second part is like quitting or saying that I think the more brilliant scientists that I know, they are super fast in saying, no, don't waste your time on this. And I think it's important to notice this as soon as possible instead of trying to fight with this. Because, for example, in my PhD, I try to, at the beginning, we try to apply our method to infer about the cosmic inflation information. We try to do it to very advanced catalog with a very complicated model that we still nowadays we don't understand it. And we try to have this goal. I struggled for even more than a year with this, and then I noticed that not big collaborations as Euclid or DESI that I talked the other day, they are not even doing this. So really, it's not feasible nowadays. And me by myself, I cannot do it. And the more intelligent part will be to have noticed this before and saying, now this model maybe is not suitable for your application. Okay. So I will say that really when things don't work, reassess.
Okay, now this brings me to another question that's somehow linked to this previous question.
Yes, many times, many times.
Then how you have you dealt with those kind of situation?
Well, as I said, I think it's all in our heads. That at least in my case and in many scientists, I come to learn that we think that this impostor syndrome, no, it's called that really the other. This is so complicated. Why I'm doing this with? Really, I can understand this, but I think the other things the same. And come on, as I said, there is not as a statistical. You can know that so few people is really brilliant. Most of us is are average, little bit above average.
So most of us having the feeling like maybe
Yeah,
I'm not good enough for this field.
I will say that's the most healthy approach to say to have these doubts. Because if you are really start to be sure that wow, this I know for sure, I have the certainty of doing this.
Okay.
That really to live with uncertainty, to know that there is other people, experts on topics. I think it's important to realize again that really your capabilities, no, and really to be honest with them because in the two aspects, because probably you just need time and
Yeah.
learn things
Yeah.
rather than to be brilliant and to uncover whatever. But really, okay, as I said, you have to reassess. You cannot be so uh, to aim for things too complicated by yourself. Okay, so maybe with need and with time and with help, you can achieve things that you didn't expect it to. As I said, we as kids, we don't born knowing things.
Yeah.
We have to learn. We have to dedicate our time. We have. I think really that these doubts, most of them are just made up by ourselves.
Next follow-up question: how do you handle the comparison with other researchers?
Well, the short answer is that I don't handle them that well because, again, always perceive that the others are doing much better than me.
Mhm.
But again, that's not true. And again, this is not a competition. I mean, I'm honest with my work. I try to put a good effort in my work, and I think the work is at the end. Maybe it's funny because in on the one hand, I think my work is not worth of it's not that good, but then I if I stop and I think about this, I said, no, it's a good work. So really, I think you need to get rid of this feeling and really, if you were honest, if you put effort in there, I think it's worth it. You know, for sure, it's going to be worth. Yeah.
Okay, I think the people who is in their early career research in academia, specifically in India, I think many young student needs to hear this out, because research is not about feeling confident at all the times. Because sometimes you do feel like you are lacking behind with your deadline, but
Yes.
that's a part of your research journey, and that's why you choose this research journey. Because when you thought of making your career in research life, it demands the perseverance, like how you are able to handle these things. So I think it's a part of your life or your research life that makes you a better researcher at the end. Don't worry, sometimes research, like when you continuing, even when you feel less motivated, but you just keep doing the things and everything will be turned out in your favor. The only thing, you just don't need to give up. Just keep doing everything as you speak. Like just be consistent with your work. That's all what matters.
Yes, and really, okay, maybe you cannot be motivated for a day, for a week, for a month, maybe a year, but um, try to hold on this. To motivation will come back, and if not, you can reassess, as I said. But really, you have to be confident that it will turn out right. And also, again, each one we have different capabilities. We are born with more. Each one has some skills in one field. Maybe I don't know. I am not good in talking in public, but I am really a good programmer. Or maybe the other way. Maybe I am good scientist in way of doing a paper of a research. I talk very nice, but then maybe to code is not a good skill of yours. So really, I will say that find your skills. Don't be afraid to ask for help. And really, I will say that with honest work and with dedication, you don't have to be crazy. You don't have to be a genius at all. I think you don't even have to be intelligent. I think you have to be passionate and dedicated work. Yeah, and also sometimes to have a little bit of luck. But that's life.
In this segment, I really want to speak about how politics affects science and research fundings, because nowadays, like the war is going on around the world. Like it's either the Russia Ukraine war or like the current situation in the Middle East. So uh like when the Russia Ukraine war started, I was in the middle of my master's degree. So the things I faced during that time, the inflation mainly, that time the prices are going so high because of the crude oil and the energy crisis, whatever. And after a few years now, I what I'm seeing nowadays, the major portion of fundings has been cut from research part, specifically in pure sciences. For example, the cosmology, astrophysics, these kind of fields. But the other fields, like for example, the quantum computing, that's really a booming field right now.
Yeah.
So Europe has put a really good money in quantum computing. So they put more funds there compared to the other fields. So that's why I really want to discuss this thing, how politics and these situation really affects your research, specifically when you are doing in the field of cosmology or astrophysics, because in those fields you don't have a direct consequences, like you have spent all time, but it's take really long. It's just kind of a serving humanity. You cannot get the profits out of it, like in the case of quantum computing field. If they would able to make the quantum computation or the quantum computing feasible, then we are on a different level, and the industry has a lot of benefits.
Yeah.
So that's why I bring this section here. So the my first question: can political decision change the science and science findings in a particular field?
Yeah, for sure. Maybe in the cosmology astrophysical community, it's not that easy because most of the output of the work, the outcome of our work, has not direct impact on.
Industries.
Yeah, maybe for example, my work of cosmic inflation. Okay, so you can put some constraints on this hypothetical particle of the early universe, that has not a direct military or interested economic application practical nowadays. But in other fields of science, for sure, can you imagine, like in nutrition, for example, you can get they can uh, try to manipulate the studies or to just bias them into thinking you that I don't know, drinking whatever drink or consuming certain product is very good for you and maybe it's not good or even bad for you. So for sure, political decision can affect directly sciences, and yeah, that's important to have a fair political system that really lets science work. Try to control, not try not to control, but will to have a good quality standards of science, and yeah, and also support public fundings without any purpose that someone is getting richer and a business is going to be do business with your research. I mean, I think it's very important for fundamental science precisely to have a strong public fundings in order to keep pushing this. And yeah.
So, have you seen any major changes in funding schemes in Spain? Like, how does war affected your funding situation in Spain?
Well, I don't know much about this. In my first person experience, I think I didn't notice about this. But again, I don't know much. The big pictures, the big picture, I have little idea. Yeah, I don't know much about that.
Okay, we can skip this because, like, in general, what I'm observing nowadays, the fundings in specifically in gravitational wave community, it's cut by half of the amount. Yeah, and for example, in Netherlands, there has been huge cuts in
Yeah.
fundings.
I heard also that in the United States,
Yeah,
there has been huge cuts of working people working in science,
yeah,
and yeah, this comes again with a price. I mean, some technology, because at the end, fundamental science and not fundamental sciences, I think there are some studies that really said that the benefits of that in the even at short term, middle term, I will say, is profitable. I mean, the one each dollar, euro, any coin that you use for science, there are many references that is one of the best investments of money. Maybe not in the very short term, but it will return as positive money. Yeah.
okay, so basically we just addresses the most fundamental question in science that I wrote it here. So I wrote the question, like the fundamental science, like the cosmology and astrophysics or the pure applied sciences, any other fields, struggles because it does not give immediate outputs,
Yeah.
as we already answered this question.
Mhm.
Yeah. So, for example, if you are in a quantum computing or the solid states or like the some industry orientated science field, then you have a really good opportunities. I would say, like
Yes.
there are will be more funding compared to other science field like the astrophysics or cosmology.
Yeah, and also one great aspect of working on fundamental science is that you get the sense that maybe you are contributing very little to the scientific community, but at least it's a contribution that, in my opinion, always adds, because having more fundamental knowledge about nature for me always adds. And it's not a concrete application to develop some material to who knows which application. It's just information, is now not, it's just knowledge that it's there. You can use it in a good way. I think some people can use it in a bad way, but I think always adds. It's just knowledge.
Okay. Thanks for answering those questions because mostly people are afraid to talk about the politics.
Yeah, well, I don't have much idea, but really it's no fundamental. It affects everything that around us. We gather as a society and we need to organize ourselves. Uh, Politics, they have to take decisions, and that is, we will be cheating on us if we won't think that science is independent of politics, for sure.
Yeah. So in the next section now, I'll be talking about the behalf of non-EU students in
Okay.
this section
Okay.
and about the PhD selection and some structural bias
Okay.
that's the non-EU people are facing nowadays.
Yes.
So many students outside of Europe feel that getting a PhD into Europe nowadays become harder compared to last 5 years.
Didn't know about that. Okay.
Yeah, because I have also seen this, but I also talk about my fellow PhD friends, or like they applied in within Europe. Few of them get selected into the PhD position, but
Mhm.
most of them didn't make it into a even single PhD position. So I also met some other people around the world. They are saying now Europe becomes more competitive, or maybe there's something going on which I don't know yet. But from my observation, when I moved to Germany back in 2021, and I stayed there for 3.5 years, in that time, I've seen more non-EU PhD candidates around the research institutes.
Yeah,
But
here
now,
in this research institute also, yeah. In the
but
last
now,
5 years, yeah,
but now that number is just decreasing. So
it's
is there?
decreasing again.
Yeah. So I just want to know your intake on this.
So I just learn about this. So no, both. I guess that's a complex analysis, but I mean that's because less opportunities are granted to non-EU students.
Uh,
Or I
I
don't
don't
know.
want to reduce it into one simple reason, but
Uh-huh.
I want to ask about like some structural barriers, maybe the visa issues, or maybe some funding rules, and maybe this war situation,
Mhm.
and honestly, the political influence, because mostly in Europe, most of the European unions are ruled by right wing nowadays.
Yes.
Yeah, and they are prioritizing EU people
Mhm.
over non-EU. And
Mhm.
I'm not against to that. I just want a fair comparison.
Mhm.
Yeah, it's all in their hands, but this is what I'm feeling nowadays.
Um, yes, I mean, for sure, that's a problem. I mean, we are starting to live in the last decades, no, in a really a global world, and really, I think that all the how do you say this? All the what's the word? Inequalities that we have. Inequalities is called between people around the world. I mean, it's always the same struggle that some people think that they worth more and they have like to defend their value or whatever ideas. But I think it's just inevitable that at the end we have like opportunities for everyone. I think science can be very democratic because I think that really if you are a good scientist and you can prove that, you should be able to get that a position as a scientist. There is a competition in there, but I think um, it could be a fair selection of who deserves this position. And I like this to be regardless of where you come from, your situation.
Yeah,
In fact,
personally, what I believe.
I will say that also if you want to prioritize someone, I will say to prioritize people with some kind of struggles that really they also deserve the opportunity more than, of course, any religion or whatever or country that you come from. Um, and yeah, I will say that I'd like to see a world in which what is important are the person getting the job and your capabilities, regardless
Yeah,
the rest.
yeah, that makes sense. Personally, what I feel, science should be free from boundaries, regardless of the nationalities, which country you are coming from, whether you belong to a specific race,
Look,
or
in my thesis, in my work, I have seen works of people from Afghanistan, India, China, US, UK, of Spain, of France, Italy. I mean, science is international already,
yeah,
but it's a problem that in some places and some opportunities are not granted to everyone.
yeah,
And what's fair, what's not fair, maybe that's a very intricate question. But really, I think science is inevitable to be international, worldwide, and for everyone.
okay. So these brings me few questions that I prepared with the help of my friends.
Mhm.
So like I come up with few questions on this section. So the first question that brought up from my friend's hand. They really wanted to know, do you think the supervisors sometimes prefer EU candidate because it makes paperwork bit easier?
Well, you will have to ask the supervisors because yeah, I have not been in that position. Well, what I can tell you is that at least in Spain, that's what I know. The bureaucracy is quite high. You have to do many bureaucracy, and I guess I'm just guessing that from people from non-EU, it will be even more democracy, more bureaucracy. But at least in my experience with my directors, and see how we have recently some many students from India precisely. I think they are happy to have students from anywhere of the world.
Glad
So
to know.
I think my supervisors they don't have much struggle with this. Here at my research center, I think it's fine.
I think it also depends on person to person
Yeah,
or on an
probably.
individual level.
Probably, but again, what I would like is that the selection is made out of your results, your
Yeah,
CV,
yeah.
yeah, even your. I will, in fact, what I like is also your motivations to count of this because yeah, well,
Okay.
okay,
So since we both are PhD students, or you are in the final year of your PhD, so the next question is based on the PhD things,
yeah,
but related with the
okay.
selection thing. So how important are the networks and the recommendations in PhD selection?
Well, again, my experience is quite limited because I don't know much about this. I only know the situation of so few people, but I can tell my situation. My situation is quite simple because I just I did my undergrad studies also here in Santander. Then I did a master in Madrid, and then I just was looking for a PhD to a PhD position, but it was I tried to look it to find a position there in Madrid, but just I tried a couple of times. It was not easy because the criterion was a little bit hard. Um, but I got like news from here from my research center in Santander that a position will be offered, and it will have that my profile can be fit in there, that I just can try to get that position. Maybe I will have some competence they cannot grant if it will be for me, but they encourage me to do it. And I think at the end, yeah, we have like another candidate with a profile more or less similar than me, but was yeah, similar. And I think that the criterion for choosing me was just that I did some work previously with them, but really I thank them for being honest, because they say that our selection really is the profile, and it was a tie. Both candidates were good, but we prefer the one that we knew already in that case. But if
Okay.
the other aspirant will have a better CV or other opportunity, will be for that other person. So I thought they were very clear with that.
Okay.
And yeah, I think that's also natural, no? To in a case of close competence to try to select someone that you know.
Yeah.
Because other aspect in science again is that you can know people that maybe they don't work as you want, they won't produce as you want, maybe you are not the best partner with these guys, and with others you know how they work before, and you know that yes, I would like to work with that people. And at the end, yeah, the supervisors are also choosing you as your student. So I think, yeah, in my experience was like this. This I received like a grant of this Spanish state,
Okay.
and yeah, I had the good luck of we we were few in the competence. But really, yeah, that's my story. And other partners that I have, they just applied for these positions and they were selected as the best candidates. I think we had the luck to be quite democratic.
Okay.
And
So
also, sorry, one last point is that in some processes there are many candidates that want to apply to this position, and it's difficult. You are eight for a position, as most likely outcome is that you don't get it. But surprisingly, there are some other positions in which sometimes there is only you as a candidate. So I would encourage people, at least in Spain, I don't know uh, which extent in the rest of the EU, at least that I know, that some positions nobody wants them. I don't know why, and sometimes you I will apply for that, but I don't get it. And sometimes they say, well, you were the only candidate, and you can get a position.
It depends on luck, I would say.
Yeah, I will say that. Yeah, and keep on trying and all of
Yeah.
this, and also the role that recommendation have. I don't know in the PhD, but as a postdoc, it's quite important. It has a bad component of because some people can be without deserving that. No, they are recommended because
Yeah.
interest and they are there. But also, as I said, if the recommendation is honest, that well, we work with this person, he's a good worker, he did a great job in this. Okay, that's a safe movement to hire this person.
So basically, I won't say every rejection is a complete bias, uh, but this is because the competition is really high, or it's a real thing in
Yeah.
nowadays. So, but I do think that we should talk about these kind of thing, whether the system is equally accessible to everyone. So in this section, we'll be talking about what are the things that needs to be improved in academia. So I would like to know, like, since you are senior here,
Well,
so you spend most of, like, you
Yeah.
are just about to complete your PhD. So I just want the honest answer based on your experience.
Yeah, okay. So, well, I had the luck, it was not in my direct experience of myself, but I think it's important to respect the mental health of PhD students and in general, if all the workers, because we are human people doing a work which is sometimes is not human, to work with so many numbers, data, connect this many analyses, work on this data all day with a screen. I think our evolution, ourselves, we are not designed to work all day with screens, with this. So I think at some point it's quite natural to that everyone at some point, maybe one more than once, we have some struggle. Also, we live our lives. We can have personal struggles,
Yeah.
whatever struggles. So I think there is still like a stigma. It's stigma is used the word. So there is still of a stigma that these guys have again with anxiety or whatever. It's an important issue, and this person can be a huge problem, and I think that's a stigma that still we need to still improve on that. And this is very close related to respect the time of others. Um, Sometimes it's quite difficult to do it. This network of working is it has a good aspect, but again, a bad one. But I think it's fundamental to respect the people, to make science the more independent of people as possible, because we can have people leaving academia, or you can have people without working because any problem, and you will need to have like a plan B, or you would like to make science as less independent possible of people, because I think that's life.
Okay.
And more aspects, that's a stigma, more aspects.
What about the publication pressure? Do you think the publication pressure is too high on PhD students?
Yeah, well, there is like many pressure to publish papers. In other fields, well, yeah, there is a huge pressure, and sometimes the quality of these papers is not the optimal one. So it's funny because there is an equilibrium, no, between asking for papers or not asking at all for papers. But I think the bias is more little bit biased to too many papers, and also in the CVs, people need in their careers to have many publications, and sometimes, well, maybe I would prefer less publications with better quality.
Yeah.
And I think, but I think in some sense this is again natural, because okay, so how we can measure the quality? I mean, maybe it's biased towards many papers, but I will say that yeah, I would like to change that, but it will be removed at all. So at the end, our way to be productive is to have papers, mostly.
Do you think the supervisors should be getting more training in terms of monitoring or like supervising the early career students?
Mm, Probably. Probably. Yeah, I will say that probably because for sure some supervisors will do a great job, but I know for sure that others are not very um, empathic with their students. Some of them have their own struggles, their own problems in their research, and for sure I will say that this relation could be improved a lot. Yes. Um, but as in general, I think we all need to know how to communicate and how to respect the others. That it's there's a lot of variance between different supervisors. But for sure, that will be another aspect to improve.
Yeah, and from my side, I would like to add one more thing that academia can improve when it comes to research visits or conferences or a workshop where you want to participate.
Yes.
But in order to participate there, you have to take all the upfront expenses by yourself. Then
yeah.
you are going to reimburse later.
Yeah,
That's the problem. I think
Yeah.
maybe people like the student who just started their PhD
Can't
they
afford to.
can't afford to go there by themselves.
It's natural.
They
Yes.
rely on credit cards and taking the loans.
Yes.
So I would really prefer if academia can improve this thing.
Yeah, for sure.
Maybe not completely, maybe partially as a first initial steps.
Yes.
Because like I came here, so I had to bear all the upfront expenses by myself,
Yeah.
and I'll be get reimbursed later.
Yeah.
So I had some saving. That's why I was able to visit Santander,
Yeah,
Bradley here.
By chance, yeah.
Yeah.
You have
Otherwise, I
luck of
won't be
this.
able to
Yeah.
came.
Yeah, that is not fair. I mean, because I think that's an organizative problem.
Yeah.
I think there is enough money to pay for this. At the end, they are going to pay anyway. So why not pay it in advance and
Yeah.
let
They
be
can
that
at least
more
pay
productive?
advance for flight tickets, the
For sure.
conference fee,
For sure.
and accommodation.
I knew people that they have been like for 3 or 4 months waiting for half their money back.
Yeah.
And yeah, I think it's not a problem that you don't have enough money to pay that.
Yeah.
It's just that the system
Yeah.
in Spain is not good. It takes a lot of time.
But I
to
like
do.
the system in Netherlands. They are pretty efficient at this because I
Nice.
got the fundings get approved within 2 weeks
Very nice. Yeah.
once I submitted all my claims.
So nice. Yeah.
And sometime the maximum time they had taken maximum 4 weeks.
Well, that's really good.
Yeah. So
And here in Spain again, it's funny because there is another quite funny aspect that really we have since 24 years we haven't updated how much money do you get because you have a daily fee that you get paid for the hotel and the food and all the
yeah,
expenses.
the per dime and all
In
that
24 years have been updated in Spain, and it's funny because for sometimes in more close to summer in Barcelona, for example, or big cities, sometimes you cannot find anything to stay. And it's funny because I don't want, I mean, I just want money for a cheap hotel near the conference place, and sometimes they pay you even more. Because I mean, if you spend less in the food, you pay a little bit more. I mean, I just want to cover my hotel, just to have normal food outside, and that's it.
Yeah.
I don't want more money, but I want the money that I need. And
Yeah.
it will be nice to have it in advance always, because you will know for sure, many of our travels are planned with enough time
Yeah.
beforehand.
Yeah.
So it doesn't make any sense to then wait for have your money back. I don't get it.
Yeah. Okay, now we are moving towards the end of this discussion.
Nice.
So I got 3 questions that I really liked. I got this question. One of my friends, she is like trying to get the PhD position nowadays.
Okay,
So-
there in India, back in there. In India?
Yeah, she is
Okay.
back in India. So she asked the first question: what is a question in your field that sounds simple to outsiders, but is actually one of the hardest to answer, and why is it so difficult?
Say how these 3D maps of galaxies are done.
Okay.
Because you say like, okay, you have I guess from the outside you see like you have a telescope, you see the light,
Yeah. And you
like,
see the beautiful plots at the end.
yeah, and you plot like this, no? Maybe okay, I say like you study the light, okay, so this object is moving like this. There are many effects that really have to be considered. Many effects regarding the Earth's atmosphere, regarding the different properties of objects in the sky, different effects that can be contaminated with, I don't know, light of other sources.
Yeah.
So it's quite to have really good measurements and to be sure that they are good. It's a complete branch of science.
Okay, and the second question she put that I really like: what is an assumption in your field that you think future scientists will look back on and say, we were asking the wrong question?
We were asking the wrong question. That's a
Really nice question, I guess.
Yeah, that's a good question, and I think that's. I will say that science is not based on saying, "Oh, they were asking the wrong question." I think even wrong answers and wrong models are productive. For example, Einstein theory wouldn't be able to be proven if so many experiments testing how the speed of light changed were not negative. I mean, they were, oh, come on, we are not measuring properly the speed of light. We fail again, we again fail. Oh, the speed of light is always constant. And all these failures, at the end, led to the answer of, well, maybe the speed of light is constant regardless of observer. So I think which question in my field, it's a hard question to address. I think probably you only can reply that in retrospective.
Okay.
If I would know this, it will be funny because I think you only can connect this back.
Okay.
Yeah.
Okay.
I'm afraid that I don't have the answer for this.
It's fine. And the last question she put: can you describe a moment in your research when the data forced you to abandon a very convincing idea, and what that taught you about how science really works? I really like that question.
Yeah, it's a good one. Well, so I have, for example, some data that look promising. I try to apply to infer the statistics that I use, and really the results were they were not precise as I wanted, and really I had like to improve my method. I have to really thought about what's going on here because I knew that data was it was a good signal to this data. It was a good precise data, and I really hope it performed much better. And yeah, moments like that are what's going on in science. As I said before, you can say that, oh, maybe there's a scientific problem in which maybe data is not good enough, but the most likely outcome is that your method can have any problem, you have some limitations, maybe you didn't did something properly well. So I think I learned that, just again reassess, just try to try different angles to approach this, and don't give up. Try to improve what you have, and let's see if it goes better. But I think moments like that happen. Yes, when you put so much effort in something, so much time, and you found that it didn't perform as I wanted at all.
Yeah.
But again, sometimes it's an easy problem to solve, others not. But the good part of science is that sometimes that's also an interesting result.
Yeah.
That this code, okay, maybe the performance was not as good as I thought. Maybe that's good enough.
This reminds me the idea of how this CMB was discovered.
Yeah, it's amazing story.
Yeah, like the people from some Bell laboratories just trying to get out of this particular signal
contamination.
And that's how we were able to see.
And it's funny, they thought it was like a pigeon's poo, no?
Yeah.
the dishes and all of this.
They removed all possible noise sources from there, but still they were not able to avoid that particular signal.
I will guess some big discoveries were about to be abandoned.
Yeah.
Like, we cannot get rid of this at all. What is going on? And you see, that would be a good question, Lord. They were asking the wrong question about this radiation. But this is like that's how science works. From the outside, it's all big discoveries and all big, what a passionate universe stuff. And at the end you find you are a little bit deceived with the stuff. Sometimes it's the other way around. It's the minority of occasions that you have something that it overperform and so, wow, I didn't expect it to work so well. But I will say that it's not in most cases. But again, science is not to have the best answer. Sometimes it's to ask the proper questions.
Yeah.
And it's to try again, try another approach, and keep on trying. Yes.
I hope this conversation give you a really good idea to our viewers, and if you enjoy this conversation, please support us. We want to make a platform where people can learn and get the better idea if research is really for them or not, so they can decide with our conversation here, and it will help them in some other ways. I don't know what will be those other ways. I just had the idea, like along with my PhD journey, I should create or make a platform for all the PhD or the students who are doing their masters or bachelors or even the schools, so that they can have a clear idea of a research life or a research from inside.
Yeah.
Because from outside it's look very fascinating.
Yes.
So
Yes.
okay, thanks for wonderful talking and
Thank you.
conversation, and I wish you all the best for your thesis defense.
Thank you so much.
Another positions, whether if you are going for postdoc or trying to find some other places.
Thank you.
I wish you all the best from
The best for you also.
Yeah, thanks.
Starting this journey. The very best.
Thanks. Okay, see you.
See you.
Yeah.
It was
we'll
very
keep
nice.
in touch.
We'll keep in touch for sure.
Yeah.
Thank you.
Okay,
Very much.
bye guys.
Bye bye.